All right, great. All right, thanks for coming. I'm going to post the link to the agenda in the chat. And I think today we can start with the metalhead discussion. If you still have stuff you want to discuss, Abhiraj.
Yeah. I do actually. So can I just go ahead?
Yeah, go for it.
Cool. So, like last GSOC, I landed a bunch of stuff that's now been released in point 8. So that sort of changed because I haven't been on these calls for some time because I haven't found the time. But I'm trying to find some time right now. So I just wanted to pop in and sort of look at where we're going with Metalhead, the repository as a whole, as well as with like the surrounding models and the weights. So sort of my focus right now is to land more docs because we have a lot of features that I managed to get in during the GSOC, but I necessarily did not have time to document. So I had one PR for this merged like just about yesterday, I think. So that is sort of the start. And my idea is that I'm slowly going to add more and more documentation so that at least we have complete documentation for what, all the changes made at from 0.7 to point 0.8. So that is sort of the initial plan. But the reason that I brought up this is I also wanted to discuss the longer term sort of direction or goal for Metalhead. Because right now it's sort of this place where we have vision models and weights. But my question is, what is it that Metalhead is sort of or looking to become or wants to become? Is it going to remain this place where we just keep these vision models and their weights? Are we going to expand to more CV related things like not necessarily image classification? So that was sort of something that I wanted to understand and discuss because if that's going to happen in the same repo, then that's a different conversation or maybe a different repo or different package of sorts.
Um, well, I think uh we haven't, or I guess the plan has never changed since what we've always had, or at least we haven't discussed anything new, which is that
Mhm.
Metalhead would contain vision models and weights, but vision can include more than just image classification. I think UNet was added recently, as part of the
Mhm.
0.8 release.
Mhm. Right.
And I mean, what were you thinking? Were you thinking of going beyond vision?
Yeah. So the thing is that right now there's a unit that is included, but I see that that's the only segmentation model that's been included. So we have a lot of classification models and really just the one segmentation model. So my question is more, if we are including models, are we also at some point going to branch out to try and include helper functions for segmentation or object detection? Or is that something that we're going to rely on other libraries to do? So in which case, does it make sense to even have just the models given when we're not giving helper functions? Because uh, if people are going to be using other libraries for this very purpose, then I don't know how well that integration will work in terms of using a model from Metalhead and using helper functions from elsewhere.
Well, what other libraries are you thinking of?
Honestly,
Or are you
I
saying
don't know.
future libraries?
Yeah, future libraries. Yeah, honestly, I don't know what the state of object detection or image segmentation in Julia is right now. I haven't really looked at too many libraries. I know there are a couple of libraries that use Flux, but I haven't exactly gone into the detail of that. So I'm assuming current or future libraries.
One, if I can jump in, one
Yeah.
aspect of this is sort of the discussion I had with Ashwana Rati in image processing on Slack and something on Zulip, because we were looking into using Onyx runtime for inference purposes. And there you would also need to have implementations, for example, of the pre-processing and post-processing steps. But those functions would actually apply to all neural network implementations of, for example, a YOLO model or a ResNet or whatever, if I'm not mistaken. So maybe there would be some value in maybe keeping just a suggestion, keeping Metalhead a Flux model implementation package, and then I don't know, having something around it or something like that. I don't know if that makes sense.
Yeah. I guess that kind of lines up with what I was just going to say, which is that we chose for Metalhead to specifically be the models and their weights for that reason exactly. So in terms of how we go about implementing something like pre-processing, ML utils would be the kind of package that facilitates the pre-processing pipeline. And then we chose data augmentation as the place where kind of all the nodes in that pipeline would be defined for standard image pre-processing tasks, at least. And then right now, the only library that I know of that kind of brings those two pieces together and makes it so that you really only need to call, 1 or 2 lines of code to get the full pre-processing pipeline for a given data set out there is FastAI. Now, if we wanted to create an image pre-processing package that depends on ML utils and data augmentation and defines these pipelines for the users, then we can definitely do that. But yeah, I kind of agree, probably should not be in Metalhead. It seems like a pretty heavy library to depend on just to get the pipelines, especially since the pipelines are flux agnostic.
Okay. Yeah, sounds good.
Right. So in that case, I think my question is basically because I am sort of trying to look at writing docs for Metalhead and especially trying to make it so that people can know that there is a lot of functionality. Is there a way that we can sort of brainstorm on writing tutorials to show people how you can use Metalhead along with these other things? Because right now, I think the major issue is that there's going to be a lot of libraries that you have to use, and the functionality is there, but people are not necessarily going to know where to look for what.
Right. No, I agree. So I think, I have no problem including those tutorials in Metalhead. I think a proper Metalhead docs should be what we're currently working on, which is API reference, and then kind of like how-to tutorials, which really dig into the different layers of the package and how you would go about manipulating things at all those different layers in the stack. But then we're really missing kind of beginner-friendly tutorials of, I wouldn't want to train a small ResNet on CFAR. How do I do that? I feel like an end-to-end tutorial that describes that should be kind of one of the first things that's there in the Metalhead docs. And those take time to write, but if that's what you're setting out to do, then yeah, I think you should, well, if the question is about what packages to actually use, and like code snippets and things like that, then I guess the easiest thing is maybe just ask the specific question on a Zulip thread, and then one of us can just reply back with the code snippet of how we've done this in the past using data augmentation or something like that. Does that make sense?
Yeah, cool. I think that's sort of a good start. So maybe I'll start writing some stuff up, and as things come up, I can probably post them, and we can move forward from there probably.
Yeah. And then I guess at least um with regards to like pull request for docs and things like that, um, you know, I guess the pull request that you just got merged is actually uh pretty small and self-contained, but um yeah, the smaller the better, at least for me on my end right now, just based on my bandwidth. So the less that there is to review in a single PR, the faster I can review it because I might have a slice of time that's long enough.
I would also vote for, I don't, maybe this was mentioned, I might have missed part of this discussion, but is like when we put together more like full examples of how things should be done, maybe we can put them in Pluto notebooks, given that then we can both review the code, but also be able to quite quickly visually see the output. And like being able to then display that on like the Flux website or something in like its rendered form as like here's the full example and you can see like what the output is, because of course image processing is a very visual thing, so it's quite natural to like see the output of each step and see how things are changing.
So
You know, it's
I'm
it's kind
sorry
of
to interject, but I've
sorry.
oh I'm so sorry. No, never mind. Continue. I just finished my point later. Yeah.
Yeah, I was just gonna say, like, from my perspective, it's hard to get motivated and hard to understand what's going on if you don't have visual examples of something that is doing a visual task.
Yeah, sorry.
Anyway.
I was just about to say that the last time I was using Flux and like even slightly big models, I was having issues with Pluto in terms of latency and getting the cells to run because it was taking a lot of time, and also because when you're running like big loops in MLI, I found that that was not playing well with the fact that Pluto wants to execute everything when the notebook starts. But I don't know if there's been major changes made on that front from the Pluto side. So maybe Jupyter notebooks work the same in terms of trying to show them on a website, but I don't
The
know if
problem
there's sort of been
Sorry, I was just going to say the problem with Jupyter Notebooks is that you can't actually see what the code is in code review. It's you have to actually open the notebook to know what it's doing, which is kind of a barrier to review, especially when maintainers are very busy. So that's why I was kind of saying Pluto, but not suggesting Jupyter for this.
I think we have a few
I-
options. So one of them, so just listing them in order of perhaps attractiveness, in my subjective opinion. The first one is that Pluto has a feature to block execution of a cell, which I think is, I don't know how well it works, but if it working well, I posted the link which implemented. If it works well, then it should be all we need to make sure that we're not running into the problem Abhiraj just mentioned, where it either tries to run the big expensive training loop cell more than once or tries to run it right at the start. That would make Pluto work. There are other solutions like, for example, using literate.jl or Weave, or I think Franklin supports using Quarto notebooks too now. So you get the Jupyter kernel, but with a markdown notebook, and you can run it in VS Code, but also have it rendered on CI. So we have options there, thankfully. It's just, well, finding one that works.
Yeah, I mean, I think SciML uses Weave, right?
Yeah, I would prefer, personally speaking, I would prefer Quarto over Weave because the tooling support is just better. Like there is actual syntax highlighting in VS Code, and I don't recall if there is for Vue notebooks, or the IDE support is spotty. But yeah, we suffice it to say, I mean, they use almost the same markdown syntax, so there is more than one option we can test for this.
Yeah, I mean, okay, well, I guess the main reason I've mentioned SciML is because they use Documenter, and I don't know, I guess as much as I would love to use something other than Documenter to do the documentation, it's really the one that gets the most attention in the Julia community. And I don't know, I feel like with the current maintenance workload for all the fluxml maintainers, trying to figure out like our own bespoke documentation system with Franklin or something like that will be time consuming. So
Yes, sorry.
yeah, I mean, I agree with you. I would
I
prefer
think I
to
can,
use.
if I can interject, I think I have an answer to that
Okay.
point. So the reason I thought about Cordo in the first place is I saw someone post somewhere. I linked an article, this is not what I saw, but basically you can use it with Documenter. Otherwise, it
Oh,
wouldn't have occurred to me that this works. I mean,
okay,
ideally,
great.
my preference again would be to use Pluto with Documenter, which I think works. Correct me if I'm wrong there. Because it's just less moving parts to handle. But yeah, whatever solution we choose, it has to work with Documenter. Like that's non-negotiable, and it shouldn't require, like you said, Kyle, any bespoke functionality to maintain on our part.
This sort of also brings us something that I was thinking about. This is the fact that right now the Flux docs are spread over different websites, and maybe it's probably best if there's a way to unite them like the SciML guys did with the SciML docs initiative. I don't know if that's feasible, but it seems like something that would make a lot more sense because things link together a lot faster, especially when there are links to things like batch norm from the Metalhead layers docs, which is something that we will need to link to, and I really can't do that without providing a permalink.
Yeah. No, I mean they use multi-documenter, so we can definitely try and pilot something like that on FluxML. I mean, I agree with you.
I think the only reason
Yeah.
we didn't try multi-documenter is that last time we looked at it, it was very, very new, and it had some very breaking bugs that Sebastian was still working on fixing, or someone else. But if it's presumably it's more mature now, so why not, right?
Yeah. Yeah, I mean, that'll also
Okay, so
avoid the situation of repeating tutorials. You know, like you don't need a separate tutorial for Metalhead. And then the same, like I would say a simple computer vision tutorial should be there in like the Flux docs as well. Because that's probably that landing page that most people end up on. And if they have to somehow find Metalhead in order to learn how to train an existing model, fine-tune an existing model or something like that, that's not a great experience. So, yeah.
So what I'm seeing on the SciML docs website is that it seems to be working fine for now. So maybe there's a possibility that we can start looking at slowly porting over the entire documentation across all the FluxML repos, or at least the ones that are really the ones that users are going to be using. Maybe we can sort of put that together in a repo and spin up a website, see how it goes. I'm okay taking like some initiative on this because I definitely want better docs in terms of having everything together in one place, because right now it's just all over the place, and that really makes it difficult for people who are trying to get into this to be motivated.
Yeah. So, I mean, I think if that's the case, maybe start with the multi-documenter step. Just, because it doesn't make sense to have, let's say, Metalhead docs with permalinks and then have to redo all the linking when you switch to multi-documenter. So, yeah, start with that step, I would say.
Yeah, and I think it might have to be done at a coarse grain level because we already on the Flux side, we integrate the docs of all its dependencies, which live in fluxml, into the Flux docs themselves or on the sidebar. And I don't know what that looks like in a multi-documenter world. Like, do you split them out, but then they're less discoverable, but then maybe it's easier to maintain and the docs can be updated independently. So it might be easier to do like middlehead plus Flux plus like parameter schedulers or something, and then try to figure out the individual lower level components where they live.
Right. Okay. Well, yeah, I think everything that we discussed sounds good. And Abira, thank you for wanting to take the lead on this.
Cool. Yeah. I'll maybe spin up something in a couple of weeks and sort of hopefully I have something, at least a demo to show by next meeting. So maybe we can discuss, setting up like initial repo, doing some checks on how it looks because that's pretty important, and then maybe slowly we can start to expand to incorporate everything. Maybe right now I can just start with Flux, Metalhead, and something else, and then slowly we can probably expand because there's a lot of stuff that's also not on Documenter, like with fastai.jl, which is on Pollen, I think now. So that's also going to be like a separate discussion. So
Yeah, I don't think we need to integrate fast AI docs in this setup, but it would be good to integrate the subcomponents like data augmentation, and maybe Flux training. And so, yeah, maybe we can talk to Lorenz about it, but it would be nice to transition at the very least data augmentation to documenter.jl, because those docs are very sparse anyways, and they need a lot of love. And yeah, I think no one wants to take it on if it means working with a system that only like is currently in development. Okay.
cool. Yeah. Yeah, that makes sense.
Do we want to move on to the next point? Enzyme and Flux integration. I think Julian, you brought this one up. I don't know if you have specific questions.
Yeah, more. I'm mostly wondering what is required to make this work. Like what we expect is required to make this work. I imagine Enzyme can work just fine with like the functional nature of Lux and Flux. But then, kind of the question is like, do we know that, for a given, like for all of the built-in layers, do we know if anyone's tried to run those with Enzyme and get gradients? And, where are the challenges in making that integration work? Like really just where the barrier is.
Convolutions. That one word answer. But no, it's more complicated than that. The question, two answers. One, depends on whether you use GPU or don't use GPU. If you don't use GPU, the answer is we put in rules for all of the kernels that Enzyme can't handle, which is currently definitely the conv ones, I think because of the threading and some weird types shenanigans, and maybe the pooling ones. And that's basically it. So like the custom functions in inlet that have their own kernels. If you use GPU, then I think we need Enzyme to be able to handle kernel launches. And just for basic stuff like running broadcasting of an array. I talked to Billy about this. They have PRs they're working on. I think we're just gonna have to wait for those. And then we'd have to add rules for example, sorry, we wouldn't have to add, depending on what the rules look like, we would either add rules for like the mutating conv with exclamation mark function, or we'd have to add rules for the CPU version of that and the CUDA AMD GPU versions of that. So the rules we'd have to add are not significant, I think. But they're not sufficient to get models running on GPU. If that makes sense.
Okay, I'm willing to ignore GPUs for the time being. I know they're key to performance and being able to like do this for real workloads, but you know, we can get there. Do you know if the like workflow for using enzyme with, I'll just say with Lux, because I assume it's probably easier to work with Lux than Flux because of the implicit parameter style in Flux causing problems. But do we know, has anyone actually tried doing like the same thing where it's that we can do with Zygote, where it's just basically like Flux dot with gradients and then call the model, and you know the model is a chain and it's got a few basic layers, you know, maybe some dense layers, some convolution layers, like, you know, like ResNet or something like that. Has anyone actually tried doing that and had success with like at least getting gradients out? And ideally also training, but like just with getting gradients out with a convenient API.
Yes. See linked issue thread. It's pretty straightforward. I don't know if optimizers.gl is currently cut out for gradients, which are the exact same type as the model. I believe I don't see why it wouldn't be. So as long as the operations work, this should work. And we might need to be a little bit smarter about how we create those how we create a shadow copy of the model using fmap, but that's kind of all small details. Oh, and there's the same caveat with like layers like dropout and batch norm where we have to manually set the train mode and test mode. But in theory, there's nothing stopping you from getting a model working with this. I don't know why. It seems like Flux runs into fewer issues with enzyme than Lux, despite not supporting the one big array of parameters. But I think enzyme has done a lot of bug fixes now, so maybe they're more even now.
Okay, and just looking at your examples, so okay, so you can basically just call enzyme.autodiff. Okay, so the D model is essentially where your gradients are going, and then
Yes.
you just need to pull them out of there, and then you can. So, and sorry, I missed part of it while I was trying to get Zoom to cooperate with me. Did you say anything about whether this works with optimizers and how easy that would be?
It should just work. I have not tried it. Optimizer should just work, but there might be some weird edge case where when the gradient type is the exact same as the model type, it doesn't work. But I don't see any reason it shouldn't.
And the idea is that basically, so D model in this example is essentially, instead of actually holding weights, it's holding the gradients.
Yes.
And then presumably you can just tell optimizers, read gradients from this model, write them into this model.
That's correct.
Okay.
Yeah.
Cool.
I mean, just to clarify, all of this is explicit, not implicit. So there's, you know, implicit is no longer going to be a thing. And there's, from optimizer's perspective, it just sees trees. I mean, that's why this works. This is just like a tree of arrays, and it just walks the trees in conjunction. And that's why it should just work with D model. But I'm pretty sure if that didn't work, you can turn D model, which is currently a model type, into this you can call fmap structure, which will get you a name tuple that has the same like tree shape with all the arrays as D model, but without any of the type issues. I don't know if that's what you meant.
What are the?
I don't know.
Yeah, I mean that sounds great. What what actually are the type issues that you're referring to?
I was just going to ask that too. Do you mean type issues with the container, or do you mean type issues with the leaves, Brian?
With just the container, like so far, all of the traversal we've done with optimizers is that you have the original model type and then you have a nested name tuple, which mirrors the structure. And we know that works. I don't think we've tried when the actual gradients are the exact same structural type as the model. If anything, it should work better, but we've not tried it. So I'm not 100% confident it'll work out of the box. It may just require like a very, very small bug fix on the optimizers
Right.
or functor side. Yeah.
Right. And an fmap structure will basically allow you to work around that. It'll give you that name tuple instead.
Cool. That makes sense. Does anyone have an example of how I'd kind of extend this to use optimizers? I want to be able to kind of play around with this a little bit and see if I can then also extend like an example with ResNet to then doing some distributed stuff. I think, because I want to be able to do training, but I don't want to, I guess I don't know why I'm specifically interested in enzyme rather than zygote, but I guess I just want to, see that working out. But anyway, like, does anyone have an example of how I would do optimization with this? Mostly because I'm not very good at
Not a
these
complete
things.
one, but the idea is you can take any example which uses optimizers with Zygote right now, and where you get the gradients, you just splice in the relevant enzyme code. And then the rest is as before.
Okay.
So I linked one example from the docs, but I think the Flux docs have a few, and there are many others scattered around. So basically pick whichever you want. You might even be able to, I don't remember if we have a Metalhead ResNet training script in Metalhead or in the test, but you might even be able to just adapt that.
Cool.
Yeah, and I shared the one-liner of code in case you run into that type issue. It's in the chat. So you just add that before the update step.
Okay. Fmap structure. Cool. Okay. That sounds good. Okay. Well, I could play around with this. Cool. We were potentially going to have, like, if this was in a worse place and needed a lot more work, then we were potentially going to have like an undergraduate at MIT potentially work on some of this if they're interested. No guarantees on that. But if you all think that this is in a reasonably good place and we're pretty close, then maybe I just, have them work on actually putting together some examples of how we do this with enzyme, and then eventually start looking at doing distributed support for training.
It's really make and break are the rules for those kernels that enzyme doesn't understand right now, like the conv. If those are in place, then I don't see any real other barriers to this. But that's a big if, right? Like there are very few examples of reverse mode enzyme rules being written in the wild.
Yeah, because it's also still a kind of new setup. Yeah. Okay. If I or whoever runs into issues with things needing custom rules written, could I just reach out and ask for help with that? Because I don't know how to do that.
If it's with the Flux side, yes. If it's with the enzyme side, I would not be very helpful. Like I thought about, oh, can I do this? And I looked at the enzyme docs and promptly decided I do not know how to do this. So if it's with the Flux side, then yes, absolutely.
Okay.
Yeah.
Cool. I was, because also part of this is that I'm hoping to at some point also be able to do training with Llama with language models or the other the llama.jl implementations. So like if no one else does it at some point, maybe I need to look at making that work. And I figured trying to do this with Enzyme would make the most sense since it's doing a lot of mutations, but it's also not using Flux, so that, yeah, maybe is not relevant.
That might make
But-
it easier, frankly, I think, because if I recall, it uses BLAS, which Enzyme supports, and then just normal plain Julia code, which Enzyme also supports. So you may have more luck with that, frankly.
Gotcha.
Yeah.
Okay. Cool. Well, thank you for all of that information. I'm also going to see, I sent some other stuff to talk about. Oh, well, I'll pause now. If anyone else has anything to talk about, then go ahead.
Hello.
Hello.
I'm new here. I can wait till if you actually have something on the agenda. By all means, go ahead.
Yeah, the only thing was discussing Llama and Whisper. But you know, I guess that was also you, Julian, so it's up to you.
I
Yeah, do
was
that.
only going to ask if people had ideas or if people were interested in these. That was really it, but I don't actually really have a whole lot to discuss with those.
Well, so Whisper uses Flux. So I don't know, I guess as far as I'm concerned, isn't it already integrated with Flux? Because I thought it uses Flux, like Whisper.jl uses Flux, and works on at least AMD GPUs and presumably CPUs. And if it works on those, it should also work on, yeah, Brian linked it in the chat. It should also work on CUDA. And then the other thing was Llama. So yeah, like you mentioned, Llama 2 and I guess language models.jl are like the low tech Julia implementations. I believe transformers.jl has a Llama 2 implementation as well. So if you wanted a Flux integrated Llama 2, you can just use transformers.jl.
Yeah, I was mostly just thinking, how do I do, not with Whisper, but with Llama, how would I do fine tuning training? But I think I've kind of gotten some answers to how that would work.
Yeah. I mean, if you wanted to use the Flux version, like in the long term, I feel like at least most of the operations in a transformer would be simpler to get working with Enzyme than like ResNet, because there's no convolutions.
Yeah, that makes
Yeah,
sense.
but I've never tried it.
I was just hoping that we could have like like my desire is to kind of have a cutting edge model that's like pretty recently out there, work in Julia, not just for inference, but also be able to do some training with it. You know, just like ideally fine tuning so that I could do it on not crazy high end hardware. And then, you know, also be able to then train some models that are good for things that are Julia specific. You know, like code completion or question answer based stuff.
Yeah, one
Yeah.
thread that might also be of interest is on Slack. There was a thread which Peter, author of Transformers JL, for those who don't know, participated in about can we use LoRa, which is a fine-tuning technique on Llama in Julia, and then there's some discussion about that is also of interest. But if it's about direct fine-tuning of one of the existing Llama models, that also seems promising. When the kind of non-Flux Llama models. So there are options. I don't know if anyone has really gone ahead and done it. And I am curious how much of a benefit it gives in specifically for using something like LoRa on Llama with Flux, because the AD is not going to be it's still doing all of the AD stuff. But it is exciting to see people working on it.
Cool. Well, I'll look into that. That's all I have.
Okay. Jonathan, go ahead.
All right. So was anyone here at SciPy? Probably not. Okay. So I recently joined NumFocus as a program manager for an initiative we're starting called Open Source Science, OSSci. And I'm going around and trying to join all the community calls for all the different projects. And surprisingly enough, this is one of the calls that has the most people on it, which is very exciting. Some of them don't even really exist anymore. But we've got, does anyone here know, have you heard of OSI yet? Do you know what it is yet? Okay, so our goal essentially, very, very briefly, is to connect these projects that y'all are building that are very, very useful for researchers to the researchers who use them, but generally do not communicate with the developer community. So we're trying to be like a social infrastructure connecting the two ecosystems. And in order to do that, we're building some social infrastructure. And we want to, like, there's a lot of high level goals, for example, getting citation credit for working on open source projects, advocating for funding mandates in open source and open science. So if someone funds research, they should also fund the tools that are used in that research, that sort of stuff. But to get to that part, we have a lot of small steps along the way. And we're building some smaller initiatives like something called the map of open source science, where we want to take all these tools, make a nice visualization on them, and tie them to the people and the papers that are produced from the tools. And one of the fields we're starting in is material science and generative AI or machine learning. So we would be super interested in learning more, particularly about Flux and the tools that run parallel to it, that are sort of tangential to it, that run downstream, upstream, anywhere around it, so we can put it on the map. And then once the map is sort of developed a little bit, you'll be able to just go to a website, and you can already go to a very, very limited mock-up that I'll put in the chat here and see what it looks like. So the project Flux will be right there, and you'll see a bunch of other projects, papers, and people associated with it right there on the map as well, so people can kind of explore the entire ecosystem of open source tooling. Another sort of initiative that we want to start up, that we've got a couple of people already excited to be involved in, is we want to tell stories of these projects and bring those stories out to the wider open source ecosystem and the wider research ecosystem. So there starts to become a human aspect to a lot of these tools. Because while obviously y'all got a very tight-knit community that talks through issues and does a lot of really cool stuff, the rest of the world frankly doesn't know about that. So we want to create a platform where we can share all the cool stuff that goes on within these open source communities with the rest of the world. So to that end, if you or you know of anyone in your community who would just like want to talk, we are always open. We have like a guest blog where if you guys go to events or just are thinking about stuff you want to talk about and want to reach a wider audience, you can post on our blog. We also have an interview series where we sit down and ask questions about the project specifically. Text, and in the future we're going to try and start some audio initiatives, maybe some video initiatives where we can do like podcasts, recordings, and get those up. Yeah, so basically I just wanted to come in, listen and see what you guys are talking about, and then invite you to join all this really cool stuff that we're trying to build with the rest of the NumFocus projects.
Yeah, that sounds really cool. Thanks for joining in. I guess, yeah, there are a lot of academics in the Julia community, just in general. So I'm sure a lot of them would be interested in this kind of initiative. Certainly, you know, many of the primary users of Flux are using it for like research purposes, where they, for whatever reason, prefer Julia over the other alternatives. And so maybe we can reach out to some of them as far as like connecting them for that story aspect that you talked about. And then for the other stuff like the mapping project, what's the best way for us to kind of get that info to you?
Yeah, so I just posted the link to the very rudimentary prototype. It might take a second to load because it's just hosted on some hardware. But we have a discourse forum where we're starting a thread on where people can just come in and throw tools and what those tools are used for, who uses them, and sort of any papers they know that are used for that. That's a public forum. I'll get the link for you. Alternatively, you can just email me.
Okay, yeah, that sounds good. Yeah, if you share the link to the discourse, we can, one of the maintainers can share the details of like the Flux web of things for the map, and then we can also share the link to that discourse with the like our different community channels. So then our users who happen to be in science can also comment on papers that they've done with Flux.
Yeah, that would be awesome. I mean, if we can get this map going, and we've got a couple people already starting to contribute to it, I think this could do so much good stuff for the open source.
Yeah, I agree.
Have you
Yeah, I'm glad.
considered advertising this more broadly in the Julia community channels? Because I know under the Julia umbrella, we have Julia itself, we have Flux, SciML, I think Grid AP is on there as well. There are a number of non-focused projects. So if you haven't done already, maybe a broader call on one of the Julia community channels about this could grab a lot of interest, more so than this particular call could.
Yeah, definitely. What do you think would be the easiest way to reach that? Is there a Slack or a forum
Discourse,
somewhere?
probably, for this kind of announcement. Yeah, and I because I don't even know if a lot of people in the community, even users of particular packages, know that their packages are part of non-focus.
Yeah, that's another thing we're trying to do is remind people that, hey, there's this really cool nonprofit that can help support development and social infrastructure. Cool. Yeah, I've added it as my bookmarks. We're just starting this initiative, this push to get it out there and get people start contributing to it. So very early in process. I will reach out to this larger discourse community. And I'm really excited for the project summit happening. I think in September. I don't know if that should be a lot of fun.
Yeah, yeah. Are you
good?
No, I was gonna say you should share the link to the date and like info for that summit as well. And there might be a few folks interested in joining.
Yeah, definitely. I don't know if I can share that on a discourse. There's a way I can email it to you.
Sure. Okay. Well, yeah, thanks for joining and sharing all that info. I think the project sounds like a good initiative, so I hope it's successful. Any other agenda items today? Anyone can speak up about anything.
One quick question is, I have been messing around with Python calling into Hugging Face transformers to get this OWLVIT kind of text vision model. I know there is some Hugging Face transformers Python call stuff in transformers.jl as well, but is there something else somewhere kind of related to all this thing with like just for inference, being able to use all those models that are wrapped in Hugging Face transformers?
I don't know specifically about transformers. Let me see if I can find the link to, there's like a package for basically calling into Python models from Flux and Julia.
Is it the PyNN training?
I think it has a different name. Let me just see if I can find it.
Okay, thanks.
Unless Brian, you have the link, feel free to share it.
The only packages I can think of are also for training. So PyCall chain rules, if you want to slap a Python model onto a Julia site and diff through it.
Yeah.
But yeah, most of them are relevant for training only and not
Yeah.
so much inference.
Oh,
I guess if you're wanting to share arrays between Python and Julia frameworks, you might want to check out dlpack.jl,
yes.
which you may already be familiar with. So, but yeah, I otherwise I'm not sure of anything on top of like just using Python to PyCall or Python call to load a Hugging Face model.
Yeah.
I don't know if there's any infrastructure on top of that in the Julia ecosystem.
Yeah.
Yeah.
I know that.
I mean, there's the Hugging Face API. So I don't know if that helps make the loading of a Hugging Face model easier, and then you could combine that with Python call somehow to actually run inference. But yeah,
okay.
Python.
It's
Sorry.
quite easy to call some of it just using Python call and nothing else. But yeah, I think the answer to my question is there's might be something in transformers JL, as I already discovered, but there's not a separate package somewhere hiding for inference with Hugging Face API or Hugging Face transformers library.
No, not that we know of.
Slightly related question is the kind of inference APIs. I think there was an issue which I just posted in the chat, also in transformers JL, that there should be an inference API somewhere. Has there been talk about this earlier?
Well, so Peter mostly manages maintaining transformers.jl, and at least I personally haven't heard anything related to that from him. And at least outside of the Flux and Zygote side of things, the, I guess, language modeling API aspects are all Peter, who's mostly leading that effort. So he would know best, and he doesn't typically join this call.
Okay, I'll try to reach out to him.
Okay, cool. Any other things? All right, well, that's the top of the hour anyway. So thanks everyone for joining. We'll see you again in 2 weeks. Yeah, have a good weekend.
Who's that?
Bye.
You too.
Thanks,
Bye.
everyone.